All right, here we go. Trig functions: sine, cosine, tangent, cotangent, cosecant, secant. Those are the 6 trig functions, right? Today we're going to look at what the derivatives are of them. Okay, so at its core, what is the definition of a derivative? Like what is, in words, what is the definition of a derivative? Like if you had to put it in words, what is the definition of what a derivative is? What a derivative does? Chrissy? Exactly. Perfect. Slope of the tangent line, right? And the tangent line, so what is a tangent line? It's a line, but what's tangent? If it's tangent, what does it mean? There you go. Only at one point. Tangent that only touches it at one point. Okay? So the slope of that line. So right now what you have is a sine wave called the sine wave. It's just sine graphed. So the values of sine up to pi over 2. Or sorry, 2 pi. It keeps going forever and ever and ever in each direction, negatives and the positives, right? So that's just one cycle of it. Okay, so now what we're going to do is we're going to find the derivative of sine. The derivative of sine. So let's start with the easy points. So derivative means slope of the tangent line. So if I have a point here, let me make it a different color. Here, that's on the sine curve, right? So what would the slope of the tangent line look like? What would the tangent line look like, I should say? What would the tangent line look like? What would the tangent line look like there? Would it look like that? No, right? That crosses. We don't cross the function. We ricochet off the function. So what would the tangent line look like? Well, the tangent line in this case would look like something like that. So what we have to do is find the slope of those guys. Well, how do we find the slope of that guy? How do we find slope of anything? Of any line? How do we find slope? Change in y over change in x, also known as rise over run, right? How much do we go up over how much do we go over, right? That one looks to be close to 1, looks to be something close to 1, right? So what is that, pi over 4? Around pi over 4? It looks to be close to up 1 over 1, right? So let's go down to our chart. The derivative at pi over 4 for f of x, which is sine, is close to 1. Let's say close to 1. We'll say close to 1. I don't know if it is 1, but it's close to 1. Pretty close to 1. Because it looks like I'm going from here, this line, the slope of this line here looks like I'm going up 1 over 1. Okay? What's another point? Look at the curve. Look at the curve. Look at the sine wave. Which x value is probably the easiest to find slope at? There's 2 of them. Which x value would be the easiest to find slope at? Yeah, why pi over 2? So what's the slope going to be at pi over 2? Yeah, look at pi over 2. At pi over 2, it's like the peak, right? It's like a maximum. The derivative at every maximum is going to look like that. That's 0 slope, right? So at pi over 2, it's going to have a slope of 0. 0. Okay. Where else? Is there anywhere else it would have 0? Is there anywhere else on the from 0 to pi, 2 pi where it would have 0 as a slope of a tangent line? 3 pi over 2. Yeah, 3 pi over 2 it would, right? 3 pi over 2, it would have Same thing, tangent line that looks like that, right? Tangent line that looks like that. Okay. All right. So let's put 0 there. 3 pi over 2, 0 there. All right. So we're trying to fill in enough of this table. I'm not trying to fill in the whole table. I'm trying to fill in enough of the table so that I kind of get a good picture, right? So what would the slope be at pi? What would the slope of the tangent line be at pi? Approximately what? What would it be approximately? What's the slope of this line here? Hmm? Not 1. You're close. -1. Yeah, I go down 1 over 1, down 1 over 1. It looks like the first one I made just going in the opposite direction, right? They look perpendicular. So it's close to -1. So we'll say -1 here. Let's see. What about over here? 2 pi, the very end. That slope kind of looks like 1. Kind of looks like 1. So it's approximately 1. Wavy line means approximately. Okay. Now what I'm going to do is I'm going to graph what I got. I'm going to graph what I got. I don't have the whole table, but I'm going to graph what I have. Okay, so let's graph. Let me show you what I have. I'll put it in a different color. I'll put it in blue. Okay, so f of 0. F of 0 I don't have. Okay. F pi over 4 I have 1. So it's about 1. 2 pi, or pi over 2, 0. Pi, -1. 3 pi over 2, 0. And then 2 pi I have it at 1. Connect those dots. Does that look familiar when I connect those blue dots? Should look like something you've seen before. It looks like you got cosine right below it, right? Cosine is the second function we're going to look like. Don't this guy right here and the blue guy I just draw, don't they look identical? They are identical. Because guess what? Guess what the derivative of sine of x is? Cosine of x. Cosine of x. This derivative of sine is cosine for that reason. That when I graph the derivatives, hey, it turns out to be cosine, right? So the derivative of sine is always going to be cosine. Okay. Now let's go to the bottom. Now let's start with cosine. Now we're going to start with cosine. We're going to do the same thing. I'm going to do the exact same thing. Try to find slopes of tangent lines. So where's good places to start for this guy here, for slope of tangent lines? Where is a good place? What x values would be a good place? I would say there's a few of them. Where's a good place? Where's good places at? Pi over 2. Let's see. Pi over 2. Pi over 2. What's the slope of the tangent line there? It's negative for sure. It is negative. I agree. It would appear to be -1, but I'm not quite sure. There's other places on there I think are easier. What is another place that would be easier to find the slope of the tangent line? Mhm. Pi, let's see. Pi is right there. Yep, that's a minimum. Minimum means low part, low peak. Yep, that's 0. We got another 0. Slope of it is 0. Good. Is there another one like that? 2 pi. 2 pi, let's see. Yep, 2 pi is right here. It's a maximum. It's a high peak. It's a high point. 2 pi, let's see. 2 pi is 0. There's one more. 0, yeah, at the very beginning. At the very beginning, we have a slope of a tangent line that looks like 0. So at 0, the slope would be 0. Okay, and then yeah, pi over 2, it looks like it's close to -1, so let's write that in. At pi over 2, it looks like it's close to -1, approximately -1. What about at 3 pi over 2? What about 3 pi over 2? It looks like it's approximately +1, right? Looks like it's perpendicular to pi over 2. So we would say approximately +1. Okay. Again, we don't have to, I'm not going to fill out everything. I'm just going to fill out just enough so I get a picture. Okay. So I'm going to get a picture here. So now I'm going to go graph those dots. So what I want you to do is go make dots where we have those points at. Go make dots where we have those points at. I'm going to do that right now myself. 0, 0. Pi over 2, -1. Pi 0. 3 over 2, 1. 2 pi 0. Okay. So those are the dots that I have. Now I'm going to try to draw that like I did earlier and see if it looks familiar. Does the blue graph now that I just drew look familiar at all? It looks like a sine, right? It just does the opposite of sine. Doesn't sine start up here, then go down here? It looks like it's a mirror of sine, right? We call that a negative sign, right? Positive sign looks like the one we started with here. This is positive sign, right? It just looks like we flipped that. It just looks like it reversed. Instead of starting up, it starts down. Then it goes up. Then it comes down. Yeah. So it's a reverse sine function. We call that negative sine. So the derivative of cosine equals negative sine. Okay. There's others too. There's others. There's derivatives of all of them. So at the bottom of your page, you have this little cheat sheet. The derivatives of all 6 basic functions. So the 2 we started with are here. Sine and cosine, right? The derivative of sine is cosine. The derivative of cosine is negative sine. And then we go to the rest. Tangent, the derivative of tangent, secant squared. The derivative of cotangent, negative cosecant squared. The derivative of secant, secant tangent. The derivative of cosecant, negative cosecant times cotangent. Why are those so, why are these true? For the same reasons that these are true. right? And we're going to do one. We're going to do, I think, tangent. I think they want us to do tangent next. Yep, tangent. They want us to do tangent next. Okay. Before we do that, though, I want you to draw something on your paper, which is going to be useful for you for a very, very long time. So let me get a little, yeah, okay. Okay, so we're going to draw what's called a cycle. It goes in circles. So we're going to start with sine. We're going to start with sine. What's the derivative of sine? We just found it out. What was the derivative of sine? Cosine. What's the derivative of cosine? We just found that out too, right? We haven't done this one, but use your brains. I'm sure you can figure this one out. What is the derivative of negative sine? Negative cosine. And what do you think the derivative of negative cosine would be? Okay, they just repeat themselves. All they do is repeat themselves over and over and over and over. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. The derivative of negative cosine is positive sine. It's a cycle. It just keeps repeating itself. So they're going to say, this is what they're going to say. They're going to say, what's the fourth derivative of sine? What's the fourth derivative of sine? You're like, oh man, fourth derivative. Well, you just go first derivative, second derivative, third derivative, fourth derivative. You get back to yourself. It's itself. Fourth derivative of sine is itself. What's the 10th derivative? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative sine. Okay, they like to ask that question a lot because they just repeat themselves. Do you know the pattern and do you know the order of the pattern? Okay, that's something that will come up a lot. All right. Okay, so before we go on to the next one, look at this paper here. Take this paper here. If you turn it over, so turn it over. We haven't used the back yet. We have never used the back. Now we're going to. The very back. So the top of the back. This is straight from your book. I didn't create this or anything. This is literally the front page of your book. So literally this front cover, the front actual first page, that's all it is. I just put it on here. Okay. So if you lose it, it's just from your book. Okay. It's got a lot of the rules. It's got all of the rules for differentiation. We've covered a lot of them. We've covered a lot of them. The first one right here is the constant power rule. It's really just the power rule. If you have something times something, you keep that something and multiply it times the derivative of whatever you're finding. This is the sum and difference rule. This is the product rule. This is the quotient rule. This is the constant. If you're taking the derivative of a constant, it's always going to be 0. Here you go. Here's the one. Here's the big boy right here. The power rule. That's just the power rule right there. Okay? Here is derivative of x, or just a single variable, is 1. We don't really use this one a lot. Natural log, these guys here, we'll get to next week. These guys here, we will get to next week. We haven't got to those yet. Those are exponentials and logs. We'll get to those next week. Today, we're on these right here. We're on these guys right here. This is what we're doing today, 13 through 18. Okay? And then the last thing we got to cover next week is this. That's it. So we've pretty much learned over half of these so far. There's a few that we haven't learned. We'll do next week. But this is all of the rules for finding derivatives. Okay? So it's a quick kind of cheat sheet to remember how to use all of those rules. Okay? All right, so now let's go to the back. Back of the first page. Okay, so using the derivative of sine and cosine, the previous derivative rules we learned, and some algebraic massaging, we will enable us to prove the value of 4 other derivatives. We're just going to do one. We're just going to do tangent. I'm not going to show you the others. I'm just going to show you. So I proved to you this guy here. Y is the derivative of sine cosine, and y is the derivative of cosine negative sine. We showed that already, right? I'm going to prove one more. I'm going to do one more proof, and that's it. Okay? The others, I can, but I'm not going to right now because it's just, you kind of get the idea. Okay. So we need to prove, this is what we need to prove, that the derivative of tangent equals secant squared of x. Secant squared of x. That's what we need to prove. Okay. So let's start with tangent. What do we know about tangent? What do we know? What's one of the important things that we know about tangent that we you learned last year? What do we know about tangent? Tell me everything you know about tangent. What do we know about tangent? Right? It's a combination of 2 others, right? Tangent is a combination of sine of x over cosine of x. Because when we use the unit circle, right, isn't tangent equal to y divided by x? That's the relationship, right? And sine is y and cosine is x, right? So if we combine them, we have tangent. All right, so let's write that down. Let me write that down. Okay. So essentially, this is what I'm trying to do. I'm trying to find the derivative of sine divided by cosine. How do I do that? No. Quotient rule. Isn't that a quotient? Isn't this a division problem? Division problem means quotient rule. So let's use the quotient rule, yeah. Quotient rule says the bottom, low, so cosine, times the derivative of the top. What's the derivative of sine? Okay. Minus the top times the derivative of the bottom. What's the derivative of cosine? Negative sine. All over the bottom squared. Okay, so I got to multiply and multiply. What do I get when I multiply cosine times cosine? Cosine squared. In trig, they write cosine, they write squared right here. In algebra, we write the squared over here, but in trig, for some reason, I don't know why, but they write the cosine, the squared there. It's the same thing. It's the same thing. It means cosine squared. Means cosine times cosine. Okay. Minus, what's sine of x times negative sine of x? The negative sine squared of x, right? The two negatives cancel out and they make a positive. Good. On the bottom, I get cosine of x squared. Cosine squared of x. So cosine of x times cosine of x, just times itself, right? Okay. So let's see. Let's see this. We have this plus this over this. Last test, this is what I saw. I saw some people trying to do this. Can I do that? No. There was a few people on the test on the free response that tried to do that. No, you can't do that, right? You guys know that. All right, since we can't do that, what can we do though? Let's see if anyone, let's see how good some people are. I think you see something, Tristy? What do you see? Yeah, it's the Pythagorean identity. Pythagorean theorem says a squared plus b squared equals c squared. Well, it comes from right triangles, right? Well, you have a bunch of right triangles here. So if I have a right triangle like this is always going to be 1, right? This is x and this is y, right? That's a right triangle. So we would say a squared plus b squared is equal to 1, right? Well, instead of saying a squared, we say x squared. And what is x equal to? X is the same thing as cosine. So in other words, we can say cosine squared plus sine squared is equal to 1. So that relationship here that I just highlighted is actually equal to 1. It's the basic, it's the only trig identity you need to know. And it's not anything new because it's Pythagorean. So you guys have been doing Pythagorean theorem since junior high. Okay? So that's equal to that. 1 over cosine. 1 over cosine. What is 1 over cosine? There you go. Just prove that. Okay. Now I could do that for all the other three, but it's just, I think it's not a waste of time, but it's just our time's better spent somewhere else. So for time's sake, just believe me, the other three have been proven. Okay, you can take these as fact. Okay, you can do this. I could do the same for all of them, right? This one I would change to cosine over sine. Do the same thing, quotient rule. This guy I would have to change to 1 over cosine. Use the quotient rule. This guy I would change to 1 over sine. Use the quotient rule. You would do the same thing every time, and you would get whatever this is equal to. Okay. All right. So now that we know that, let's go ahead and actually do some problems now. Let's actually do some problems. All right. So let's look at 4a. I don't think this is number 4. I think they skipped numbers, but we'll go 4a. Let's look at 4a. How do you think I'm going to solve 4a? Take a wild guess. I'm not looking for the answer. I'm not even looking for the first step. I'm looking for how. How do you think I'm going to solve this guy? Yeah, product rule. Because this guy is x squared times sine of x. These guys are separate. X squared is not a coefficient. X squared is not a coefficient. It's a function being multiplied times sine of x. So this is a product rule problem. Okay? So let's set it up so. Product rule says the second no wait, the first times the derivative of the second. So the first times the derivative of the second. The second is sine of x. The derivative of sine is cosine. Plus the opposite. The second times the derivative of the first. What's the derivative of the first? 2x. Okay. Clean it up. We can't really do anything with it. We have x squared cosine of x. The only thing I would do is move this 2x in front of sine of x. It's really nothing you can do. You can't combine them because they're not like terms. Wait, what? Okay. All right, so what I want you to do now is try B. Try B on your own. We've used quotient rule. We just used it not too long ago. I think you guys can do it. So do B. Find the derivative of that guy. Okay, so quotient rule says low, D high. Low times the derivative of the high minus high D low. Derivative of the bottom is just 1 over low squared, or low times low. So low D high minus high D low over low, or low squared. Okay, so clean it up. Let's see here. I'm going to move the negative to the front, so I get negative x times sine of x minus, multiply these two guys, I just get cosine of x over x squared. Can I do this? No, I can't. What would need to happen for me to be able to do that? What else would need to be there? If this guy had an x, I could do that. But because that guy doesn't have an x, I can't do that. Okay. There you go. All right. All right, here we go. Let's try this guy here, g of t now. So g of t, I'm just going to use, they're adding, right? They're adding two terms, this guy and this guy. So I'm just going to find the derivative of both of them. Well, before I do that, I need a power and I need a coefficient. Okay. That's just the original function. That's just the original guy. Now that I have powers and I have, this guy doesn't have a power, but I know it's a trig function, so I know how to handle that. Find the derivative. 1/2 t minus to the negative 1/2 plus, I use power rule here, move the 1/2 over here, subtract 1 power. That's how I got that. Go to your list. What's the derivative of secant? You can go to the pink or you can go to your notes. Either one. They're both on there. What's the derivative of secant? Yep, secant x. So secant t times tangent. Since we didn't use x, we're just going to use t here because that's what they used. Okay. I still have a negative here, right? So I got to take care of that. So I get a 1 on top, 2 on bottom. So it's going to be root t plus secant t times tangent t. Okay. All right. Okay. All right, let's do the last few. Okay. Got a couple more. A couple more will be done. I think two more, that's it. Yep, two more, that's it. Okay, so here we go. We need to find the derivative. Well, before I find the derivative, what do I have to take care of? What do I have to take care of here? It's h of s. Mm-hmm. Yeah, I got to take care of that, right? So how do I write that instead so it's got a power? Yep, s to the negative 1. Now it's got a power. 10 times cosecant of s. Okay, power rule. Going to move the power to the front. So negative 1 is going to come to the front, and then I'm going to subtract 1 from it. So negative 1s to the negative 2. That's the derivative of this guy here. 10 is a constant, or sorry, coefficient. So 10 is just going to come along for the ride. It's just going to be 10 times whatever the derivative of cosecant is. What is the derivative of cosecant? Go to your list and find out. Hmm? Negative cosecant times cotangent. So they both get an S, right? Okay, so I have this guy here minus this guy here. Okay, I have two terms. So the first thing I need to do is this guy here, I got to get rid of the negative exponent. Okay, so I have negative 1 over s squared. That's how I do that. Move that to the bottom. Right? Minus this guy over here. I have a 10 and I have a negative 1. So when I multiply those guys, I'm going to get negative 10. And then I have cosecant, not cosine, cosecant of s times cotangent of s. Negative times a negative makes a positive. There you go. Okay. All right, last one. Last one. Try that on your own, see what you get. X times cotangent x. Multiplication. So product rule. Product rule says the first times the derivative of the second. So the first is x times the derivative of cotangent. All right, well, I look at my list. Derivative of cotangent is right here. It says negative cosecant squared. This guy means if there's another derivative. If there's another derivative, find the derivative of that. But we don't have that, so we're just going to use this guy right here. Okay. So negative cosecant squared of x plus the opposite. The first times the derivative of, or sorry, the second times the derivative of the first, which is just 1. Okay, clean it up if you can. What I'm going to do here, I'm going to move this negative sign to the front and then multiply these two guys. So I get negative x cosecant squared of x plus cotangent of x. then you're done. The nice thing about trig is that you don't have to go further, right? There's not a lot of work here. If you guys looked at the notes from last time, where was it? A lot of work, right? We had a lot of work there. With trig, there's not a lot of combining like terms. There's not a lot of doing that kind of thing. So it's nice. The only bad thing about trig, though, is that if you don't know these guys here, you're out of luck. Okay. So I always get the question, do I have to memorize that? Here's the thing. You only have to memorize things that you don't use, right? Memorization means it's something like you don't have to remember your cell phone number. You don't have to remember your address because you always use those things, right? You always use those things. Things you always use, you remember, right? That's the thing I say with these. We're always going to use these guys. So the quicker you put it into your long-term memory, the easier it will be for you. If that means flashcards, that means flashcards. If that means just working with these guys all the time, go for it. But the easier your life is going to be if you know what's the derivative of cotangent, negative cosecant squared. What's the derivative of tangent, secant squared. What's the derivative of cosine, negative sine, right? If you know those things, the faster you know them, the easier this will be, right? So that's what I say. So whatever it is that you use to do those, that's what they are. Because like I said, I mean, you can prove, like I proved this guy, and this guy, you can do that, but that takes a while. And you don't want to do that every single time you need to find derivative of cotangent. You like just to rattle off. Okay. So you're going to see them quite a bit this whole semester and next semester. You're going to see these guys quite a bit. So this semester, since we have a few minutes, this is what we're going to do. This semester, this is what we're doing. We're finding derivative. So we're going this way. Right? Next semester, guess what we're going to do? We're going to go the other way. It's called integration. Integration is just going the opposite direction, right? So it's kind of the same thing. So we don't do a lot in calculus, but we do a lot in calculus because we go deep. But the stuff that we talk about, like I said, that's essentially what we do. Like we spend a whole semester going this way. What's the derivative? What's the derivative? What's the derivative? And then second semester, what do? We just go the opposite way. What's the antiderivative? Right? That's calculus right there. Okay? It's just we go deep. We go very deep into this stuff. Okay? That's the only thing. All right. Okay, so let's see. Monday, I think we're going to go on to something new. Yeah, so I'm going to post an assignment on this today. It won't be due till Tuesday, but I'm going to post an assignment just so you can practice on this. Okay, I'm not sure if it's going to be on Delta Math or if it's going to be a worksheet, or it might come from your book. I'm not sure yet. I have to look to see what my notes say. But yeah, there will be something posted by today. It won't be due till Tuesday.